Today, we will pit two of our most extreme scientists against one another. Caitlyn and Dan will be competing to demonstrate the most extraordinary, extreme, and exciting science experiment with the secret ingredient, liquid nitrogen. We need the Boys and Girls Club to decide the winner.
Liquid nitrogen, the coolest thing at Imagination Station. Literally, it's 320 degrees below zero. That's cold. So, let's take a look. I've got liquid nitrogen right here. I can pour it into my beaker. Let's take a look. You can see that it's giving off this water vapor right here, and it's actually boiling. What's really cool is that it's changing from a liquid nitrogen into a gas, nitrogen gas, which is all around us in the air all the time. But it's boiling away, and as it boils, the gas expands and takes up more space than the liquid. And to show that, I've got this. This is a tea kettle. You might have a tea kettle at home to boil water to make tea or coffee, but today we're gonna put some liquid nitrogen inside. Now, when you boil water inside of a tea kettle, and you close the lid, when it starts to boil, it whistles and makes a whistling sound, and we can tell that our water is boiling. So, when I put my lid on top of this tea kettle with my liquid nitrogen inside, if it's truly boiling, changing into a gas and taking up more space, then it should make a whistling sound. Let's test it out. All right, here we go. Let's close the lid. Did you guys hear that? It made a whistling sound. All that liquid nitrogen on the inside is boiling away and changing into nitrogen gas, expanding and taking up more space, getting pushed through this tiny little hole and making a whistling sound. What a cool experiment.
Dan's tea party was pretty cool, but we are gonna have a blast with this next experiment. I'm going to pour liquid nitrogen into this test tube here and then cap it with a balloon. And we'll see what happens as that liquid nitrogen expands into a gas. Let's check it out. Ready? We can see that liquid nitrogen is boiling and it's vaporizing from a liquid into a gas. And that gas takes up hundreds of times more space than the liquid does, so it's filling up our balloon very rapidly. I'm a little impatient though, and I want this to go a little bit faster. So I'm going to pour all of the liquid nitrogen into the balloon, and we'll see if we can get it to pop. Ready? Here we go. Oh. Did you see that? That little bit of liquid nitrogen from our test tube expanded to such a great volume of gas that it popped our balloon. Can you top that, Dan?
I don't know, Caitlyn. That seems like a bit of a stretch. I've got an experiment that also uses balloons, but this time we're gonna put it inside the liquid nitrogen. This balloon is filled with gas, normal air. And if I put it inside this liquid nitrogen that's 320 degrees below zero, that air inside this balloon is gonna cool down. And when it cools down, instead of the liquid nitrogen changing from a liquid to a gas, the air, which is a gas, is gonna change into a liquid. Let's check it out. I've got my liquid nitrogen inside this container, and I'm gonna put it inside. I'm pressing my balloon with the air inside and changing it. You can see the air inside is starting to take up less space because it's being condensed and changed into a liquid. And when I pull my balloon out, we might be able to see the liquid inside. All right, let's check it out. You guys see that? There's liquid inside of my balloon. That's liquid air. And as I take it out of my liquid nitrogen, that liquid boils away and expands and changes from a liquid into a gas.
You're right, Dan. Putting a balloon in liquid nitrogen is pretty cool. But what about putting this many balloons in liquid nitrogen? Let's try it. Check that out. We fit every single one of our balloons and Dan's rocket balloon into this dewar. They're all inside here. As the cold liquid nitrogen cooled the air inside of the balloon, it contracted and actually turned into liquid air. Now watch as we pull them all out again. Look at all of our balloons. As they warm up outside of the liquid nitrogen in the room temperature air, that liquid air evaporates once again, vaporizing into gas again, taking up hundreds of times more space than they did inside of our liquid nitrogen dewar. Top that, Dan. Let's take this to the next level, all the way up to the stratosphere. We're gonna make a cloud right here inside of Imagination Station. That's right, a cloud. It takes just 3 things to make a cloud. Moisture in the air, which I have inside of this jug that has warm water in the bottom. Particulate matter, which is the dust and debris in the air around us all the time. And an extreme change in temperature or pressure. And I have just the thing to make an extreme change in temperature. My liquid nitrogen. It's negative 320 degrees Fahrenheit. Compared to the warm water inside of this jug, that's almost a 400-degree Fahrenheit difference in temperature. So let's see what happens when I put some liquid nitrogen into this jug. Ready? Here we go. By adding the liquid nitrogen, we created a cloud so big that it burst out of the top of this jug. How cool is that?
That's right, Caitlyn. You do need 3 things to make a cloud. You need water and moisture in the air, an extreme change in temperature, and particulate matter. But if you want to make a really big cloud, you need a lot more of it. Liquid nitrogen cloud in 3, 2, 1. Woohoo! Science!